Topic 10, Current of Electricity. Part 3 is to do with resistance and Ohm's law. Resistance, symbolized by capital R. Resistance can be described as an impediment or restriction to the flow of current. In other words, the greater the resistance, the smaller the current, or the smaller the resistance, the greater the current. Put it simply, resistance is inversely proportional to current. Another way of looking at resistance is you can look at it as a means of converting electrical energy into some other forms of energy. In the case of light bulb, electrical energy is converted into light and heat due to the high resistance of the filament inside the light bulb. Now you have to find a definition and a formula for resistance from the dictionary yourself. The unit for resistance is ohms, symbolized by this omega. This is how you set up to find the resistance of a resistor, the experiment we will do in class. This is a variable power supply, and you get a set of data and plot voltage against current, and you get a line like this. Should be a straight line like that, and for the gradient you can work out the resistance. Normally we plot current against voltage because voltage is the independent variable, that's the one we control, but the gradient will give us 1 over R instead of R. So it is more convenient to plot voltage against current so that the gradient of the straight line will give us resistance straight away. Ohm's law, copy down definition yourself, but note, V equal to IR, this formula is not a statement of Ohm's law. Here is something that's important to note. Resistance is not always found by finding the gradient of the current versus voltage graph at a particular point. You can do that only if the graph is a straight line. When the graph is a curve, it is calculated by dividing the potential difference or the voltage by the current at the point in question. Take the example of this graph here, which is a curve, not a straight line. And to find the resistance at a particular point, say this point here, you simply divide the voltage at that point by the current at that point, not the gradient. Some experiments will be done in class to find out the current voltage characteristics of some components. For a metallic conductor at constant temperature, the graph is a straight line like this. This is the symbol for a diode. This is a forward bias. It allows current to flow this way. And this is reverse biased. It will not allow current to flow this in the reverse direction. And this is a typical graph for a diode. This is forward bias. That's reverse bias. We don't normally worry about that. When the voltage is forward biased like this, there will be current flowing and the lamp lights up. Here, the voltage is in reverse bias, as you can see, and there is hardly any current flowing or no current flowing. This is a typical graph for a filament lamp. We just look at the positive half, don't worry about this other half. As the voltage gets higher, the filament also gets hotter. That's why it's a curve. The temperature doesn't stay constant. This is a typical graph for a thermistor. A thermistor is a resistor whose resistance decreases greatly with temperature.